Welcome to our first video on with data structures and algorithms, and we're going to start this off by talking about asymptotic notations, which is basically the growth of functions. And we're going to talk about this because later on when we try and define time complexities of algorithms, this is going to be very useful to us. So we're going to start off with big O notation. What big O notation is basically an upper bound on the order of growth of a function. Now that's kind of arbitrary, so we can define it mathematically, which will be a little easier. So we can say that if there exists, that means there exists constants a and b greater than 0, obviously, such that let's see, we can say that f of n is less than or equal to a times g of n for all n greater than or equal to b. If these things are true, then we can say that f of n is big O g of n. So this is still kind of difficult to visualize, so let's visualize it. And we'll just draw a graph here. This is n. And we can say that this is f of n right here. And we'll use this color. We'll say g of n is here. So a times g of n is here. And here is our constant b. So you can see that from here, f of n is always less than or equal to a times g of n for every input n greater than this point right here, b. So this is an upper bound. It's f of n will never be greater than this function here. If we can do an example that will help us to understand this. So if we say that, let's just take a function f of n is equal to n squared plus 17n plus 1000, and we'll say that g of n is n cubed, and our question here is f of n big O g of n? Well, all we have to do is just kind of use our definition, plus 17n plus 1000, and the definition said that this is less than or equal to our constant a, where's my color, a times g of n, which is n cubed. And we also have that this must be true for all n greater than or equal to b. So we can just pick a number. We'll say that b is equal to 1. Actually, it's a bad spot. Let's say that b is equal to 1. So if we plug that in, we can see that this becomes 1018. Find out that that is less than or equal to a, and there's our answer right there. So if a is greater than or equal to 1018 and b is equal to 1, then it's true that f of n is in fact big O g of n. And another way to say this, that we'll see it, is f of n is big O n cubed.